Welcome to Berkshire Guitar Amplifiers again. Stuart Smith in the workshop as always, and today we have a Fender Tremolux, which is quite an old amp. I think I might have seen one or two before, but it's fairly rare, so we'll be interested to see what's going on inside this. And it's a bit of a sad old girl actually. I'll show you in a moment. It's been rather sadly neglected. The guy said he was at a gig and the power just died, and then he went to check the fuse and it kind of fell apart in his hand or something. So maybe it's as simple as just the fuse holder, or maybe it's something a bit more complicated. Anyway, let's have a look at it. Okay, I'm not sure if you can see or not, but it's absolutely filthy, this tweed Vibrolux. It's really been in the wars. Probably never been cleaned or looked after in any way. I know some people like their amps to look like this, so I might give it a clean, but I'll check with the customer first, because I've done that in the past and people have been horrified that I've cleaned up their filthy amps. Look at the state of this. And along the top, not too bad on the top there. Here's the fuse holder he was talking about. He hasn't even got the fuse and the bit that's in there, so the first thing I'm going to do is just bypass that fuse holder. And also notice that I've got the back off at the moment. I notice this wire here which goes to the fuse holder has kind of fallen off. So we can have a look in the back. It's a 115 volt or 120 volt unit, this, and they've got a step down transformer here. So I'm not sure the origins of this. Don't like this kind of thing, so I'm going to have to sort this out. This is really dangerous. It's been like that for years, I expect. So we need to get that tidied up. I also noticed the mains plug is non-standard. I'll show you that in a moment. But meanwhile, let's just have a look inside here. It's looking completely original to me. These are all the original capacitors, electrolytics. These yellow ones are all original. These are the original 25 microfarad, 25 volts usually. There'll be a dog kennel behind here somewhere, probably here, when we take the chassis out, and that will have almost certainly the original electrolytic HT caps in. Here's a rectifier. Look, isn't that amazing? Look how old that is. Absolutely ancient, that. So that's doing the rectification for the HT, I think. Here's the HT winding here. A couple of 6v6s, a 5U4 GB rectifier, and then the usual slew of preamp valves. Original Jensen speaker, nice. Probably worth a fair bit, this amp. Just out of interest, how old are these? That's falling out, that valve. So we have a 12AX7. I can't see the make on that, so I'm not sure what that is. I'll pull the others, we'll have a look. Right, so I think the first thing I'm going to do is just to bypass this fuse here, bring it up on the variac and see if it powers up. You never know, it might just be a fuse holder problem. And then we can ask the customer how much he wants to spend on it in terms of upgrading it, because this has never had any work done at all on it. God, look at this resistor here, look. It's 3 dots. Didn't see those very often. So I'm guessing this is 60s, this amp. Okay, I've got a crop clip lead there, just bypassing that fuse holder. There's no fuse in the circuit, but it doesn't matter because I'm going to gradually bring it up on my variac here. Little device I made some time ago. It's been very useful. Allows me to switch in a series lamp as well to check for short circuits. 145 volts. We go over to the amp and oh goody, the lamp is glowing there slowly, or lightly I should say. So I think I'm fairly confident about giving this full power now. I don't think it's going to be this fuse holder, because he said, you know, that the power went during a gig, but he then checked the fuse holder and it came apart in his hand. So we'll just put this up to full. There we go. And the lamp's lighting nicely, which is good. Are any of the valves lighting? Yeah, I can see that one's glowing. Rectifier's warm already. I can see the glow in the 6v6 here, can I? Yes, slight glow there, look. So the valves are all working. Can't hear anything out the speaker. Speaker's plugged in. Okay, very quiet. So it's not looking promising. I think I'll just plug a guitar in, but I don't hold out much hope here. Okay, guitar plugged in, and absolutely zippo coming out of this, nothing. Alright, so it wasn't just the fuse holder, it was something else. I'm not going to do too much more diagnosis with the chassis in place here, for the reason that we're going to be having to do some work on this amp anyway, I think. It's not just a question of quickly finding a fault and fixing it, which I may be able to do from here. I want to see what's going on. It's hanging on loose. There's so many things on this amp that I think we really ought to be looking at. It's a question of what the customer wants to do in terms of spending money on it. It's never had any money spent on it, so does he want to spend a fair old bit of money and get the thing kind of up to scratch, or does he want it to leave it exactly as it is and do the bare minimum? And customers vary in what they want. So I'm going to pull the chassis, which also means, by the way, taking out this, which I want to do anyway, because of this problem. And let's see, it's all. Yeah, I'll just take the whole lot out. I think, get it up on the bench, then we can see what we're doing. Maybe there's no HT or something on this amp. Right ho, with a bit of struggle, we got the chassis out. And here it is up on the bench with the step-down transformer behind it. This is this problem area I want to sort out at some point. This is a little doghouse, so under here we'll find some HT caps. Output transformer, choke, mains transformer. Anyway, next thing to do is to get the lid off here. I know what I'm going to find under here. I'm going to find 3 or 4 original HT caps, so let's have a look under there. Okay, screws are out, so ready for the big reveal. But before we do that, I think we'll cut to a 5-minute commercial break, selling you a load of stuff you're not the slightest bit interested in. No? Oh, okay, alright, let's have a look then. So, oh, nothing underneath there. How very strange. Ah. Look what we have here. Oh, original Mallory HT caps, absolutely as fitted in the 60s when this was made. No sign of leaking, interestingly enough. And look how these leads are soldered. That's very interesting, never seen that before. So the negative of each lead goes through a hole which has been drilled into this dog kennel, and then it's soldered, look, onto the dog kennel. How interesting. So the ground for this, it doesn't have a separate ground, this little assembly here. Picks up its ground through the chassis, and here are the 3 positives coming off. Can't see the values, they'll probably be 16 microfarads or something. Let's have a look. 20 microfarads, look. 20 microfarads at 500 volts. That's not bad. 500 volts for 1960s is quite something, actually. And as you can see, no real sign of leakage. I'll have a closer look there. Well, in order to actually kind of get the amp working, I want to see if we've got any HT. So I think, interesting enough, not so easy to do once you've got the chassis taken off like this. I'm going to have to ground this to the chassis and then see if we've got any HT across these caps. That would be a good start, I think. And then it's not too long before I call the customer and say, basically, how much money do you want to spend on this? Do you want to get it up to spec, or do you want to try and carry on with these old caps and not spend any money on it? And that's a real personal decision for the customer. Anyway, shall we see if we have any HT? That would be a good thing to do, I think. Alrighty then, the amp is plugged in, switched on, the pilot light's on. I've got the chassis grounded to the chassis here with this crock to crock lead, and we will see if we have any HT. So here we go. So I'd expect to see some sort of HT here. Ah, we've got 0.8 volts. Well, not quite enough. 0.8. What a weird arbitrary value. Okay, well, the problem here is no HT. Why do we not have any HT? The next thing to do is I'm going to bolt this back on just to save it flopping around. I'm going to turn it upside down again, and I'm going to see if we've got any AC HT. In other words, is the winding from the transformer, the mains transformer, giving out the correct voltage? Right, continuing the diagnostics process, I just want to see what's happening around this rectifier valve here. So we've got two yellows coming here. They are almost certainly the 5 volt AC for the heater of the rectifier valve. For some reason rectifier valves have a 5 volt heater compared to 6.3 volts on other valves. I'm sure there's an historical reason. Anyway, there we go, look, so we've got 4.87 volts AC on the heaters. So the next thing we want to do is to check these two red wires here, and they will be the HT winding from the transformer. They're almost always red, and I'm hoping the HT AC is there. If not, we're going to be looking at a faulty power transformer, which will be a real pain. So let's turn this up and see if I can get onto these reds. That's there and here. Ah, goody goody. Ooh, crikey, that's high. 640 volts AC. But we know it's not being loaded at all, so that would almost certainly come down under load. So we've got AC and no DC. Obvious thing to do is to change this rectifier valve and see if that's the culprit. So let me see if I've got one in stock. Yes, good news, I've got a brand new 5U4GB. We're still in the middle of our worldwide valve shortage as I film this, so I'm not sure how easy it will be to get replacement valves. My stocks are getting a little bit on the low side. I'm just going to let that cool down because that's quite hot now. Okay, you're seeing this as I'm seeing it. I have a new rectifier valve in. I've grounded this dog kennel here with this green lead, and I've just freeze clipped the meter across so that we can see it. So what should happen if it is the rectifier valve is this DC should come up after a little while. I've also plugged a speaker in just in case it all comes to life, and we can see. So there we go. Oh, crikey, that's come up immediately. Somewhat surprising, actually. Oh, and I can hear the amp working. Well, that's a little bit surprising that came up so quickly. Is it warmed up? No. I'd expect that to take a little bit of a while as the heaters came on. But that's come up immediately. Well, good news. It looks like a faulty rectifier valve. I can hear the tremoloing away. Just be a little bit careful. I've got HT just on the bench here. Just plug in a... Well, the amp's working, folks. Oh, it sounds lovely. Well, that's good news. I wasn't really expecting such a quick fix, to be honest with you. We've got lots of stuff to do yet, of course. We want to check the bias, see what's going on there. Well, that's good news. So now I'm in a position to go back to the customer and say it's X pounds to fix the faults, and that's going to be, you know, sort out this mains transformer, put a new fuse holder in, put a new rectifier valve in, and give it a bit of a tidy up. Or do you want to spend considerably more money and start changing out all the electrolytic capacitors and stuff? I don't know how I feel about that sort of thing these days. I know people watching this channel have varied views on it. I err, I think, on the side these days of not doing anything. Unless the amp is completely gig critical, and if it goes down in a gig, that's kind of the end of the world. For an amp that someone doesn't gig and plays at home, and it's working, why get involved in changing all the electrolytic capacitors, changing all those signal capacitors, spending hundreds of pounds on the amplifier? Because if it fails, it doesn't matter, just bring it back to me and we'll do it at that point. It could be 3 years, 5 years, 10 years, or never. And it does leave the amp in original condition. Now, of course, if any of these were leaking or anything, that's a completely different story. Or if some of the amp functionality wasn't working, of course, we have to get in and start changing components. But I kind of err on the side of not doing that these days. I get a lot of messages from people saying, oh, you know, at 15 minutes 35, whilst you're in there, why didn't you change C42? Those are always going, those capacitors, always a good precaution to change them, and I would have taken out all those resistors and put in modern flame retardant ones, and so on and so on. And it's all valid, of course, but it's all money, it's all time, and you know, in the end of the day, the customer's paying the bill. So I'm going to call the customer now, and I'll report back to you on what he has decided. Right, I've taken the 4 nuts and bolts off the top of this transformer. Before I open this, by the way, I did look up this amp, and it's around about 1960, maybe even late 50s, so it's quite old. I'm just waiting to hear from the client. I've sent him a message. Well, nothing terribly exciting under here, and well, apart from the transformer completely encased in pitch, so there's absolutely no chance of repairing that. So we have here the leads, and fortunately this hasn't been rotated too badly, so in other words, these aren't all tangled up. So I think with a bit of luck we'll be able to push this back through here, and then put a cable tie on the inside to stop that coming out. Ah, there we go, good. Look, that's come through quite nicely there now. Don't know if you can see that. Let me show you if I can. You can see in there, look, the cable has now come through, and I can put a cable tie on there, and that will be good enough to clamp that. It doesn't take a lot of strain, this, because the cables going into it are clamped to the case, so it's not as though it's being pushed and pulled all the time. But I didn't really like that hanging around out there, so I'll just get a cable tie and do that. The customer's definitely going to want all these little jobs done anyway, so there's nothing lost by us pushing on and doing this, putting a new fuse holder in, putting a new mains plug on, and that sort of thing. And then we can wait to see what he decides about any kind of major refurb. It's not just money for the customer. Sometimes it's money, they don't want to spend another £200 or £300 on it, but sometimes it's just they want it left as original as possible, and I totally get that. And as I say, if the amp isn't gig critical, it doesn't really matter if it fails. You just bring it into the amp tech and get it fixed. There we go, that's nice and anchored now, that's not going anywhere. And we can now just put these nuts and bolts back in. Well, I had a suitable fuse holder in stock, so I'm going to fit this one. There we go. I'll give that a little bit of a tighten in a moment, but relatively easy to fit. Voila! That is well in there. I'll give that little half turn with a spanner in a moment. Right, that's a couple of jobs done. I notice, I don't know if you've noticed, the bend look in this chassis. Have you noticed that? So basically exaggerating, it's like this. So that's had a real bash at some point. I might see if I can do something about that. It would require me putting, let me think, I have to have a think about how to do that, how to get enough force on there to push that out. Might need a bit of ingenuity, or not, as the case may be. Anyway, that's that. Still not heard from the customer. What else do we have to do? We have to put a new mains plug on. In the UK, I know you American viewers find these plugs weird, but they're actually pretty good. But in the UK now, this is illegal. We have to have plugs with plastic from there up to there. In other words, kind of that part shrouded, and that's to stop you putting your fingers in like that and pulling the plug out and getting a shock. And it also stopped the terrible British practice. I know you'd never do this in the States, of course. In the old days, if you wanted a little bit of extra power, you would wind a little bit of a lead round here and round the other one, plug it in, and you'd have a live lead coming out here for something else you wanted to power. I haven't seen that done for decades, but that obviously would stop that as well. Yeah. So I don't know what it's like in other countries, but wiring a UK plug, you might think, oh, simple, anyone can wire a plug. It's actually not a very easy thing to do. And in a recent survey that I read, less than 5% of people know how to wire a plug, and that is diminishing, that number, because of course everybody is buying things with moulded mains plugs on the top. Every appliance you buy has a moulded mains plug. It's quite rare these days to have to actually fit a mains plug. But it's I would say it's a far from trivial thing to do to wire a mains plug. You have to get the lead lengths exactly right, you have to strip them correctly, quite fiddly. Yeah, I mean, I might just quickly show you, I won't show you everything, but I'll show you once I've taken this plug off here, what's involved in doing this. And the fuse needs to be changed. British plugs are fused, very sensible idea. But they always come with 13 amp fuses, which is the maximum sort of thing you'd use on an electric fire or a kettle or something like that. Something that pulls quite a few amps. But for anything else, we pull out those fuses, we chuck them away. I will be putting a 3 amp fuse in here so that it doesn't burn the house down if it ever goes faulty. Here's the original plug look, and it's got this 13 amp fuse in, which it shouldn't do. That's very, very bad. Basically, you want a fuse to go when the current exceeds, I don't know, maybe double of what it should be pulling. So if something's pulling an amp and it suddenly pulls 2 amps, maybe you put a 2 amp fuse in there. If something's pulling 3 amps, you need to put a 5 amp fuse in. But this would only be pulling, if it pulls half an amp, I'd be surprised. Ugh, that earth is terrible too. So you've got a 13 amp fuse in. And of course what that means is, if a fault condition develops in the amp and it starts to pull a lot of current in a fault condition, it's got to pull 13 amps before it will blow that fuse, and that could cause loads of things to burn out, a major fire even, things could burst into flames. It's a ridiculous overkill to have a 13 amp fuse in a low power piece of equipment. So if you're a Brit watching this and you've got anything like this, I would check your fuses, particularly on your gear. Just take, it's good practice anyway, by the way, just to take the fuse top off. For example, this earth here is absolutely terrible. It's a few strands of crappy wire, all tarnished. Not a good earth, and you'll often take these apart and find that the earth's hanging off, or that this screw here is just finger. Oh, if it's just like that this screw here is sort of finger tight, and the leads are about to fall out. So anyway, there you go. That's junk now. Because this is in such bad condition here, you know, half the strands are gone. Look, and it's just all tight. I'm just going to chop this back to here and see if we can get a new, a little bit more of a sensible, clean. We might not be able to, because with these older cables, they tarnish kind of all the way in, or quite a long way in. Don't really want to have to replace the mains cable if I can avoid it. I don't know why I'm showing you all this, but I know some people find it interesting. I thought I might show you the way I strip mains cable. I'm sure I'm going to get letter and postcard about it, but you know, if you've ever tried it, it's not particularly easy to get this outer sleeving off without you know, damaging the inner cores. So the way I've always done it, you know, the last 50 years or so, is I put a sharp bend in the cable like that, and I just use a scalpel and go around it very gently. It's like a surgeon's approach to this, until I can just see the inner cable. I normally wear an eyeglass too for this, like this. It varies from cable to cable how much force you need, and that kind of opens it up like a wound. Right, and just now see that, those inners there, and I just carry on. See that that's now stripped, and I just carry on going around doing that. Right, so back to the drawing board. We're going to have to start again and put a new mains cable in here. I don't know how I'm going to be able to show you this. You may be able to see. First thing is, when I pulled off the rubber sleeving here, when I pulled this off like this, these inners came off with it. Now that is not because I nicked them, I definitely didn't. They've just come off. And now when I look at the cable, for example this earth cable here, you can see when I bend it like that, you see it's just all cracking and broken along its length. Anywhere you look, you've got a little crack opening up. And so the rubber, these are rubber coated wires, and it's 60, actually it's, how old is it? It's 1960, so it's yes, it's 60 years old, and that's not going to be good enough. I can't really accept that. All of these inners will be the same. So I'm afraid we're going to have to put a new mains cable in, which of course means we have to go back to our transformer there and undo what we did earlier and put a new mains cable in. And also, it's not going to be particularly easy because the new cable is going to have to be soldered somehow onto the tags of the old cable, because it disappears off into the pitch of the mains transformer. I've just chopped another foot off this cable and stripped it back again, and you know, this problem, it's not so bad here, but look, if I just get hold of this green wire and give it a pull, look, see how that just broke off of there? Get hold of this black wire and just pull, and off it comes. So I'm not very happy with that. I think we need to reject that mains cable and put a new one in. The sad part about that is, of course, you're going to miss the incredible thrill of watching me wire a British 13 amp mains plug. I mean, I just don't know how you're going to get through the rest of your day without that, but I'm very sorry about that, because the mains lead I've got has a moulded plug on the end already, so we don't need to put one on. Got this lead here, which oh no, tell a lie, that hasn't got a moulded plug, but anyway, that plug's going to be fine. We'll check it, but that'll be fine, so I don't need to put one on. Right, what have we got? Earth goes to the chassis here. That's going to be straightforward. Oh, that's not too bad actually. Live goes up to this selector switch, that's alright. And black. One of these is going to disappear into the pitch, I just know it. Yeah, this one. So the neutral, I'm going to have to just take this tail here, strip it off, and connect the neutral of the new lead into there. The others can be soldered on, so that's good. So all this work we did here, waste of time. So I'm just going to chop this off, and the tails will remind us where everything went, not that we need reminding. There we go, so that's that old cable, and that's for the bin. So I'm going to strip off the new cable, put it in there. Will it go through that grommet? Cool, yes it will. How amazing. And yeah, and then just solder that in. I won't bore you with that, it's fairly straightforward stuff. I'm just going to solder the new cable in, put the cable tie back on, put this back on, and we're good to go. I didn't show you kind of quite correctly what I was doing there with the scalpel. I don't normally go right down to the inner cables. I judge when I think I'm kind of nearly there, and when you put this hard bend on it, quite often the thing just opens up like that. See how that opened up there? So you don't need to cut through the last bit of the outer. It just peels back by itself with the pressure you put on here. Right, that's the cable back in again, all connected up, and we can now just put the lid back on, and we have a nice brand new cable rather than that horrible perished old rubber thing. I should have looked at that first, of course, before repairing the damage. Okay, lid back on, and how interesting. Here we go. Take the top off this, and immediately we have 13 amp fuse, so that needs to go. I always just check that these are tight as well. I'm sure they will be. This is a brand new lead, that's why it's got a 13 amp fuse in. I'm just going to grab a 3 amp. There we go, UK 3 amp fuse. Pop that in, top on, and there we go. That's the main side sorted out. We have new cable, and we have a new fuse holder, and I suppose I should just plug it in and power it up and make sure it works. You can assume it does unless you hear otherwise from me, and now it's a question of sitting tight now, waiting for the client to come back to me. Right, so I've had a word with the customer, and he wants to go the whole 9 yards and replace all the electrolytic capacitors and to do a full revalve. He wants the amp sounding as good as it can get, and so I'm happy to do that. They do need doing. So I've got some nice F&T 22 microfarads at 500 volts here, which I'm going to use for these instead of the 20 microfarads at 500 volts. Anyway, positives are all down. Positive, 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 positive. These two are in parallel to give 40 microfarads, or in our case 42 microfarads. We could actually put a 47 microfarad at 500 volts in there. I think I might, I don't know, let's try and leave it as kind of like it was as we possibly can. Certainly would would be sensible to put a 47 microfarad in there. And I'm going to follow the same system here. I'm not going to get clever and try and run some ground lead back down through here. We're going to just slavishly follow what they've done here. I know it's all discharged because it's been unplugged for some considerable time, but let's just be sensible here and make sure there's nothing on here, and there isn't. Just about a volt and a half on there. Right, so we can, I probably won't film all of this, but we can just literally take these off of here if they'll come. Sometimes they won't. God, yeah, that does not want to come off there. Right. Do the subtle method. And we need to remember that the red one goes to the 47 microfarad dual. I'd like to get these desoldered from here if I can, and they may just unsolder, or I might need to get the heat gun on here just to warm this up. I could use a bigger iron, of course, but that means me getting my huge soldering iron out. There you go. A bit of an effort, but they do come out. Ouch! And as the can warms up due to all this heat, it makes these progressively easier. Two. I'm going to take a view on the non-electrolytic capacitors. Ideally I don't want to change them if we can avoid it, and what I think I'm going to do there is just pull, I don't know, maybe take the ends off 2 or 3 of them. They're all very similar looking caps, and then just get the mega on them, see if any of them are leaking. If 3 out of 3 are good, I think I'm just tempted to leave those tone caps in there. People get a bit more precious about tone caps than they do about these electrolytics. Now, how should we go about this? These are obviously smaller caps. So I'm tempted to cut a piece of wood and put that in there, and then mount these caps on there. That means we can mount them on the wood prior to putting them in there, and that'll just kind of lift them up a little bit. Yeah, I think I'll do that. Okay, there's a little bit of scrap wood that I cut, and that's going to sit in there, and we're going to mount the caps on there like that, and we can just glue that in now with a little bit of a... We remade this Evo stick impact adhesive to be non-solvent based. By the way, I'm not using the non-solvent based one, and it's like a white milky stuff. I don't know if any of you have ever tried it. Absolutely flipping completely useless. And I noticed that you can't see it so much in the shops anymore. So it looks like they made a glue, solvent free, that didn't even work. You're supposed to put it on, and when it goes clear, in other words not milky, that's the time that you can press the parts together. But it just never went clear, just sat there milky for 10 minutes, half an hour, and when you touched it, it was just all wet, so it never really dried. Whereas this stuff goes off quite quickly. I'll just leave that to go off a bit, and then we can push those 2 bits together, and that'll be that done. Okay, there we go. Put that on there, give it a good old press, and that will be fine. That won't come off there. So the plan now, I think, is to put these through here like this and to line up each capacitor like this, solder these on, then I can lift up these ends, put maybe some silicone rubber down there and put them back down again before doing the final end. So I think with that in mind we can fairly simply start with this one. So I'm just going to tape this down here to make my life a bit easy, and I think in order to solder this I'm going to warm up the can a bit with my heat gun. I didn't do that when I desoldered, but it'll make my life easier soldering. So I've got my heat gun and I suspect that will just make our life a bit easier, so that we don't have such a massive heatsink going on when we go to solder this. There we go, that worked very well. So whilst I've got that heat in that chassis, in this little mini chassis here, I'm just going to put the others in, making sure I get them the right way round. I'm glad I had these in stock because the customer wants the amplifier fairly quickly, and I'm going away, so it's actually very useful that I had them in stock. There we go. I think a little bit more heat from the heat gun. Rightio, there we go. Positive, 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 positive. Yep. I'm just going to just draw around each one to give me an idea where to put the silicone. Like that. Now I can just bend them out the way and get my silicone gun and put some silicone sealant down there, and we can put them back down on top. Okay, I normally use hot melt glue, but people have been shouting at me to use silicone sealant, so I will have a go at that. This is the first time I've actually used silicone sealant in this application, so we'll just put a little blob down there. Yeah, that seems to work quite well. It's just a bit more flexible than hot melt glue, which tends to go a bit rigid. There we go. Last one. Nice. Okay, well that worked quite well. I've trimmed these down now, and we're going to put a bit of heat shrink sleeving on each of these, so that when we make the join we can then just cover it with a bit of sleeving. And I've twisted these two together, and if you remember, that went to the red one here. Like so. Right, next thing to do is to tin those. I like to kind of alternate between videos where I show a lot of working like this, because I know a lot of beginners watch this channel and they don't like it when you just cut away and say, and there you go, I've put in all the smoothing capacitors, and then the next thing to do is the resistors, and 10 minutes later just do a quick cut, show you all the resistors have been put in. But of course other people are fairly expert and this is just very easy to them. Watching this, they know exactly what I'm doing here, and I've done it 20 times themselves, so it can be a little bit boring, you see, so it's quite difficult to get the actual ratio right. Let me just show you what I'm going to do on one, which should be fairly obvious. I'm just going to join that to that. Yes, it's going to be a lap joint, folks. It'll be good in 50 years from now, I promise you. There we go, perfect. And now we'll just put the heat shrink over there like that, and the old gun on it. And that's the idea. So we will just now do that onto there and that onto there in the same way, and we're good to go on that. That's great. There we go, all done, and that's all ready to be put back in now. Everything's nicely soldered on, and nice new caps in there, so that's good. One job done. The next thing we can do is the other electrolytics, of which I think there are 5. Well, since we're playing, I've got a brand new 22 microfarad 450 volt capacitor on my capacitance meter, and it's measuring 22 microfarads. Amazing. So let's just try one of these. This is 20 microfarads, remember, not 22. Let's see what it reckons this is. That's interesting. 30. Oh, yes, it doesn't like it very much. 36. Yes, it's interesting. It's wobbling around a bit. Look, kind of shows you these are a little bit on the dodgy side, I think. Let's try this one. Ooh. I've just blown up my meter there, I think. Would you believe, people, I've blown up my capacitance meter. I don't know if you saw that. Basically, this cap still has some charge on from when I was doing the 500 volt test. And when I connected it to the meter, it put, not 500 volts, probably put a couple hundred volts across the meter. And blew it sky high. So I've junked, that won't be fixable, I've junked a perfectly good capacitance meter there. That was silly. Well, you know, I wasn't thinking. I will just take it apart and see if there's a little fuse in there or something, you know, a quick blowing smooth fuse, but that's the end of that experiment. Oh well. Right, the next thing I'm going to do is to turn the amp on, just to make sure that that work we did in the doghouse is fine. So there we go, that's on, and we want to make sure the amp comes to life and plays all right. Yeah, that's working okay. And what I wanted to do is measure the voltage across these two caps here, which I'm pretty sure are bias caps, because they've got 150 volt capacitors in there at 8 microfarads. These days that's 10 microfarads at 100 volts, and I think these have only got 50 volts or something across them. So let's just have a quick look. 65 volts across there, 26 volts across there. Yeah, so we can put in 10 microfarads at 100 volts in there. That's good. That's the next job. Okay, this is not such good news. I just pulled out this 0.03 randomly, this capacitor here. I've got the Mega connected to it, and when I press the button, you see the needle goes up, but it doesn't come down to infinity. That capacitor is leaking. It's 6 meg, but that's a 6 meg resistor DC path there. Now, just let me put a brand new cap in here. This is a 47 nanofarad at 630 volts. So put that in there, press the button, and see that immediately has gone to infinity there, look. Second you press it, it gives a little blip as the cap charges up, that goes to infinity. Put this back on here, look, on this point 0.3, and this is leaking. It's got a 6 meg resistor. Right, we're going to do one more, and then we'll take a view on this. It's going to be a bit of a shame if we have to change all these caps, but I've got a horrible feeling, you know, we're going to have to. Right, here's the next one, 0.01 at 400 volts, nothing special, I just happened to pull that one, press the button, and infinity. So that one is okay. Yeah, so now we're in the position of having to go through every single cap, I think, and assess each one. What a pain. Yeah. Of course, the other thing is if I do another one and that's no good, maybe we could say 2 out of 3 are no good. We'll change them all. It's hard to know what to do, isn't it, really? Let's try another one. Okay, next one, which is this one. I really dislike this kind of turret board stuff, because you can't often just pull a capacitor. I went to pull several capacitors, but they take the leads down through the turret board and then sort of under the board up to another point or something, so you can't get the actual capacitor out or the component out. Anyway, we've got this 0.1 at 200 volts here. Whoa, leaky as anything. I mean, I know we're putting more than 200 volts across it, but that should be. And just to prove it, here's a 0.1, brand new 0.1 at 250 volts, and bump immediately, look, in infinity resistance. So there you go. So we've got another leaky capacitor here, 2 out of 3. All of these, I think, you know, are going to have to go. Oh, look at that, leaking. That's 600k. So effectively, you're trying to block DC from something, and effectively you put a 600k resistor in there. So this amp's going to be all over the place in terms of what's going on inside it. Right, well, I think we don't have any choice really but to consider replacing every single capacitor in this amp. What a shame, quite a big job as well. This one's easy to get at, I can just unhook it from the tone control there, and that one's okay, look. So again, we've got a mixture of results here. I think we'll make this the final one, 0.02 at 400 volts DC. 3, 2, 1, don't. That's hopeless. Anyway, that's still way too much leakage, so these are all leaky, these caps, and they all need changing. Right, hope the customer's got deep pockets. It's quite a rare and unusual amp, so it's worth spending the money on. It does get expensive when you're changing every single capacitor in an amp. So the customer has given a go-ahead for a complete recap, so that's what we're going to do. The video is already getting a little bit long, so I won't obviously film every capacitor that I change. We're going to put these two in here and here. Slight difference in size, I think you'll agree. And we're going to put these 100 volt 10 microfarads ones here and here. So that's the first thing I'm going to do. Then I'm going to turn on the amp to make sure it still all works. There's nothing worse than doing a huge amount of work on an amp and then you turn it on and it's not working. And you have to try to backtrack to find out what mistake you've made. So I'll do that and then show you the result. Righty-ho, I've replaced the two bias caps and this one, the two 25s at 25 volts. The amp is on and seems to be working okay. So now the proposal is that I start changing these tone caps. I'm not going to do them all in one go. I think I'll do them 3 at a time or something. I'll do those 3, turn on the amp, do those 3, turn on the amp, do those 3, 4 or whatever, and then just make sure that the thing is working each time we do a bit of work. I'm also going to have to check the resistors after I've done this because some of those might have gone out of tolerance. Okie dokie, you can see I've put in 4 new caps, 1, 2, 3, 4, and the amp still works okay. So that's okay. I shall now do another 4. Here we are again. We've done 1, 2, 3, 4, 5, 6, 7, 8. Just those 3 to go, and we are good to go. I've checked all the resistors, and yeah, they're out of tolerance, but nothing dramatic. So I'm going to leave well enough alone on those. So we're getting close. I'll pop those 3 in, make sure the amp still works, and then we're on to revalving and checking the bias. I see that these two 6v6s aren't even matched. They're different makes even. So we'll get a pair of matched JJ 6v6s in there and change the preamp valves too. And then we're getting close. Okay, everything replaced, including this strange little thing here. That is a 500 picofarad capacitor, apparently. I had to look up on the schematic, and I have no idea whether it's leaking or not, but it's very, very old, so I've replaced it with a little 500 picofarad capacitor there, and changed that one there as well. So we're all good. Turn it on. Tone control works nicely. Sounds lovely. So that's a complete recap. Very pleased with that. That's really brought that up into the 21st century now. So I'm going to turn it off, and next thing I'm going to do is to put a couple of new 6v6s in and bias it. Before I do the bias, I thought you'd like to see the results of these capacitors. We took out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 capacitors, and so I'm just going to test them now on the Mega to see how many of them were leaky and how many of them were good. Very badly leaky, so that one's no good. Put the good ones on the left and the bad ones on the left and the good ones on the right. 0.1 microfarad. Better, but still leaky. Look, 50 meg, so that's no good either. Bad. Terrible. 1 meg. Bad. That's 3 out of 3 bad ones so far. 0.01. That's good. That's gone up to infinity, so that's okay, that capacitor. I'm not going to keep any of them anyway, I'm just going to chuck them all out. I'll just put that on the right so that we can have a count up. Another one, again leaking. You know, it's fairly high resistance, 40 meg, but it's still leaking. Next one. Terrible. 7 meg or whatever that was. Another bad one. Good. That's okay. That's the second good one we've got. So far we've got 2, 4, 5 bad and 2 good. That one's okay. 5 bad, 3 good. $50 meg, that's bad. Yeah, that's a bad cap, I mean. And this 0.1. Again, 50 meg, so that's a bad cap. What else have we got? Let's try this funny little thing here. This will probably be okay. It's quite a low capacitance, 500 picofarads, so that's probably almost certainly alright. And indeed it is, so that was okay. And then this one's a little bit hard to get on the end of. I might see if I can do this. Let's see. Don't want to electrocute myself. Bad. 30 meg. Right, so the verdict is all these caps here are bad. 2, 4, 6, 7. And these are good. 7 plays 4. So that was a well worthwhile doing exercise, don't you think? To change all those caps out. Brilliant. Okay, let's move on with the biasing. Okay, I've got the amp running and I've got a bias meter in there with the new 6L6s in, a pair of JJs, and we're running at 340 plate volts and 37 milliamps, which is too high. Should be about 25 milliamps. So these tubes are running too hot. To change the bias on this, if you decrease the value of this 56k resistor here, it will increase the current. So I need to increase the value of that 56k resistor, and to do that, what I'm going to do is I'm just going to chop, cut that lead there. And I'm going to put my resistance decade box in on a couple of croc clips. And I can just dial in various resistances in series with that one, or I might just put it across there once I've chopped that one out. And then we can get the right resistor and then solder it in. So I'm just going to turn it off for a second, and then we will just quite simply cut this resistor out. We don't want it anyway. And I'm going to clip the decade box across where that resistor was. And hopefully I'm going to put about 56k in there because that's what it was. I'm just dialing up 56k. Very useful little box this. They're quite expensive, I'm afraid. I've just put in 56k there, so we start off with the same resistance. Turn it on again. Monitor the bias, make sure we're not going to get runaway bias or anything. Should come up to a similar sort of level, which it is, look. So now I need to increase this resistor, don't I? So I'm just going to go up. You see the bias is coming down, look. Let's try 82k, since that's the preferred value. Oh, look at that. You don't get lucky that often. So basically with an 82k resistor dialed in, there, look, we get the correct bias. So I'm now just going to turn off again, unplug, and I'm going to change that resistor there for an 82k and recheck the bias, and hopefully we are good to go. Okay, there's a new 82k resistor in there, and here is the voltage and current coming up, 23, 24. We only want about 25, it's not super critical. And there we are, 25 exactly, so that's perfectly biased. 26, we don't mind about 2 or 3 milliamps either side. Job done, nice. Okay, so now we can turn that off and take the bias probe out. Put the power valve back in, And the next thing we want to do is to change these preamp valves. So let's see what we've got under here. I'll clean the sockets on these as well. So we've got a motley selection here. So this is a Sylvana. We might put these on the valve tester just for fun. This is the Brimar 12AX7, and this is a no idea 12AX7. Very old valves. We'll stick them on the valve tester, but we need to change those. I'm going to put in a new trio of Sovtex, I think. I've given the valve bases a squirt of deoxit, but actually they looked pretty good, so I don't think we need to overly worry about that. We're getting quite close to finishing this. It's been a bit of a long video, I'm sorry. Some videos are a bit longer than others. But I hope it's been interesting for you. There we go. So now we'll turn it on again, I think, and make sure it all works. And then the final thing I want to do is to get it up on the power meter and see if it's producing full power. Not quite sure what this should be producing, but maybe 30 watts, I don't know. Something like that, I'll have to look it up. Right, so you know, that sounds a lot louder than it did before I changed those valves. You know, I think that's made a big difference, changing those preamp valves. Doesn't that sound lovely? Beautiful. That's a whole different amp now. I tell you, that is really sounding lovely. Okay, I have the amp connected to my dummy load, and a scope probe is attached across the load. Trails off to my scope here, and I can turn up the signal generator. I've got a 1 kHz signal going in, and as we turn it up, you'll notice there's the output. Look, on a ×10 probe, I'll turn it down so as not to strain the amp too much. So there we go. That's squaring off. Look at 29 volts peak to peak. So now we just need to do the sums, and I'll do that for you now. Okay, here we go. Our peak to peak sine wave is 29 volts peak to peak. We need to find the DC equivalent voltage of that. It's obviously 29 volts because it's only that for a short period of time. It's something much less than 29 volts. To do that, we halve that. In other words, we take the peak from there to there, or from there to there, the same thing. That comes out at 14.5, which of course is half of 29. Power is V squared over R, so we need to find out the DC equivalent of this sine wave, and to do that we multiply 14.5 by 0.707, and that comes out at 10.25. So 10.25 volts is the DC equivalent of a 29 volt peak to peak sine wave. Okay, we're home and dry now because power is V squared over R, so 10.25 squared is 105, that's V squared. R is 8 ohms in my dummy load, so the power is 105 over 8, which is 13 watts this is producing. And I looked it up on the internet, and this amp was nominally a 15 watt amplifier, so we're not far off there. So this amp is producing the correct power output. All that remains now is to put it back together and deliver it to the customer. Well, I hope you enjoyed that one. I certainly did. Lovely to work on such a nice old amp as this. There aren't many of these around, quite rare. and we've brought it up to scratch, and it's good to go for another, let's hope 50, 60 years, long after my time. I did check with the client and he didn't want anything done whatsoever with the Tweed. He wants it in this totally filthy condition. Sorry, I know he's watching this video, and that's not unusual. I'd say 9 times out of 10 customers don't want the case cleaned. They want it left, I don't know why, looking used and gigged and whatever. So anyway, that's another job doesn't need doing. So anyway, I'm going to leave you with that, and hope you enjoyed it. Thanks as ever for watching, and I'll catch you on the next video.